Alright, so today is day 22. I'm gonna show exactly what I did. And today was mostly watching this, I finished it completely, this 4 hours tutorial from Andre Carpati. Such an excellent tutorial, such an excellent instructor. This is the last video from the playlist, from his playlist. And yeah, I basically finished all the videos. All of them were really nice. And this one is like a building on top of all the previous work that he already did. For example, the backpropagation, then he explained a bit tokenization, how do you construct transformer from scratch, GPT. And in this video, he builds more into actual training, So some optimization tricks, and those are really, really nice. For example, he covered, I believe, 5 different like tips. The first one is that you can implement, for example, a line of code in Torch in which you can specify that the matrix multiplication can be done under a different type of floating point. For example, the normal one it's float 32, but he explains all the architecture and that the GPU has, and that in most of the code, like in most of the models, the thing most important is the matrix multiplication. So as long as you optimize that, like you optimize the whole training process, and you can use something which is like a smaller version of float point 32, which is TensorFloat 32, which is this one, which in essence is the mantissa, which is the last 23 bits. You chunk them into only 10 bits. You clip them, and in this way you can make the train faster. And when PyTorch use this, technically you are using 32, so it's just from the CUDA side, like from when you run it inside the GPU actually. So yeah, that's it. So you still have like some bandwidth bottleneck. And then there is another optimization. You can either improve even further, for example, using the autocast method. And this one works over BF, which is, I believe, brain float, BF16, which is even like a reduced version of the precision, which in essence is like you have some amount of bits that represents there are like bins over different types of, like a sensitivity of how many different numbers can a bit store. And then you have the exponent and the mantissa. The exponent is like the range, and the mantissa is like the precision. And this one remains the exponent, so the range is not the one affected. So it has improvements over the float precision 16, which is basically you don't need to make a standardization or a scaling of the data before passing into the training and in the GPU. And there is also another interesting optimization, which is to use the method .compile, torch.compile. And this one, what it does, it like looks ahead all the instructions that PyTorch is gonna do and optimize torch compile, and it optimize the instructions because if we have the GPU, in order make like some process and send this like to another space in memory, and it has to access and come back like for every operation. And if I'm gonna perform like some sort of operation within the same like input, I can do it without having to read and write, go and come back again. So there are like some sorts of optimizations that you can do using this method, and it's mostly recommended to use it like always. There is also to use, for example, flash attention instead of like the normal attention implementation, which is an algorithm which computes attention faster. And then also another method, this is like an interesting trick, is to use all the numbers, the hyperparameters that you use, they must be powers of 2. Because the kernels inside the GPU's CUDA, they're optimized for doing like some sort of pairs, like in pairs. And what else? He also talked about very deeply about the distribute data parallel, and it was really interesting. He implemented replicate GPT-2 in 8 GPUs, and there are like some sort of functions and some you have to take into account mostly the size of the batches and how do you um, how do you distribute the process, how it's going to be merged again. And finally, when he trained the dataset, the dataset, he explained that he was going to use. He also talked about the hyperparameters, like all of them. For example, the use of Adam W instead of normal Adam, beta one, the amount of like all the hyperparameters, the weight decay. What else? Also, the dataset that he was going to use, it's fine web, which is like a revised or like filter dataset. And then in this case, you have to make shards because you cannot train the whole dataset, and then the implications of using shards. And finally, the benchmarking. How do you evaluate if your model is good? And he's basically using HelaSwag, in which basically it's a dataset in which you have HelaSwag, and you have like a multiple question. It's like this. So given a question, the model, because it's a completion model, it will give like a probability of the next token, right? So you can compute like the log likelihood of the next token for all tokens in the sentence. So you can get like a normalized loss for each probability for each option, and you take the one that the model thinks is the more probable, and that's gonna be the one you choose, and then you do it like for a pack of the dataset, and you get like an accuracy. And he recreated this and got like a pretty good accuracy, almost as good as GPT-3. So it's a really good model for a 10 times smaller one. So it's really nice. What I would do next, probably I will try to recreate some of it. I'm not sure what I'm gonna do next, but yeah, I would say I have to do now something more practical. It was really interesting, all this playlist, and all thanks to him. All right, that's it.